This next section is going to go over scatter plots, and we're really just going to go over the very basics of scatter plots. Hopefully it's going to be a review for most people. If not, that's okay. But if you've taken a class that delves more into scatter plots, this is going to be the little bitty intro for it. Now, scatter plots are going to take our data, and we're actually going to have two different variables, an x and a y-axis. So we're actually going to be on the Cartesian coordinate plane from when you graph things like an algebra. We haven't seen a lot of our other displays do this. Our box plots, our dot plots, they all just had one horizontal axis. Now we have our horizontal and our vertical axis. And we'll talk about those units in a little bit. The first thing I want to talk about is what's called our correlation. We want to know whether this data is going up or basically going down. So remember, we read left to right, just like we would read on a number line. So we have 0 and we go up as we go right. We get to larger numbers. So we're reading from left to right. So if I read from left to right, it looks like this data is going up. So we say that this has a positive correlation. If you remember back to your algebra days, we are not going to be writing an equation of a line, but if we did, this would have a positive slope. So we'd say it's positive correlation. The contrast to that over here, if I'm reading left to right again, starting on the left, my dots are going down as I go toward the right. So this would have a negative slope, or we would say it has a negative correlation. Now we could actually calculate what this correlation is if we wanted to and we had programs, but that's not going to be the purpose of this class. So we're not going to be doing that. Now my last data set here is I read from left to right. I don't really see a clear correlation. I don't see things. Some of the dots are going up and some of the dots are going down. It just kind of looks they're scattered everywhere. So we'd actually say that this guy has no correlation whatsoever. So our first goal is to be able to classify different graphs as either positive, negative, or no correlation. So I'm going to take a look down here at an example, and this one should be in your note packet. So right here, I've got some data on a person's age, and then also how many times they go to the movies. So I graphed it on the x-axis. I came over and somebody that was 26 years old, I interviewed them, and they went to the movies. It looks like, maybe like 10 times. So there's my plot right there. So first I want to know what type of association this is. And this one actually has our trend line, the line in the middle there, and it should be right in the middle of our data. If you did some of this in high school, you might actually use a graphing calculator to draw this in for you. For us, the trend line is just going to be right in the middle. It doesn't actually have to touch any certain dots, but we should have about the same number of dots above the line as below the line. So we've got our trend line there, so it's even easier to see that this guy has negative correlation. As you get older, you go to less movies. Now, we have to be able to also answer questions based off of this. Now, all my questions are going to be answered based off the trend line, so that purple line in the middle, not based off the dots themselves. So again, I'm going to get my answers from this trend line right here. So I want to know how many movies did the average 25-year-old attend. So here's 25 years old right here. I do not want to go to these dots. I want to go straight up to where it touches this trend line. So it looks like it's right here. I'm going to have to eyeball, or maybe if you have a ruler or a piece of paper, you can pick it up, but it looks like it's going to be in between 8 and 12. So I'm going to go with 10 movies that the average 25-year-old attended. Same sort of thing if I'm going to give you the movies and we have to figure out the age. We're always going to be answering it based off the trend line, not based off the data point. So a person that attends 16 movies, here's 16 movies right here. I'm going to go straight over to my trend line. Don't stop at this point or all the way over at the other point. I want to go all the way to my trend line, and that trend line looks like it's sitting right above 22 years old. So that would be my answer for that one. Again, make sure you use the trend line. It is a trend. I'm not saying that I actually have a data point there. I'm using it as an estimation, what in general is going on. The last thing that we want to be able to cover is if I give you a set of units, if you could tell me whether it is positive, negative, and no correlation. Now, I realize you do not have these in your notes packet. This was going to be an activity that we did in class, but, you know, since there's not going to be class, we're just going to go ahead and do it online here. So looking at these, I want to know if one goes up, does the other one go up? Or if one goes up, does the other one go down? Or do they have nothing in common whatsoever? So education and income. As you get more education, do you get more or less income? Is kind of what the question is. If they're both more, then it's positive. If one's more and one's less, then it's negative. Think about your slopes again. If you had a positive number over a positive number, it's a positive slope. If you had a positive number and a negative number, it's a negative slope. So if you have more education, you do get more income. So we would say that this guy did have a positive correlation. Might just write POS the next time. The number of pets a person has and the number of books a person reads. These have nothing in common whatsoever. So we're going to say that this one has no correlation whatsoever. The number of days absent from school versus your math average. This one's going to throw it in here just as a little, you know, make sure and keep up with your work. So if you miss a whole bunch of days, so as you increase the number of days you miss, the trend, not true for everybody, but the trend is your math average would go down because you're missing more material. So you've got that number of days increasing and your math average decreasing. So that would give you a negative correlation there. So why don't you hit pause real quick and see if you can try the rest of these guys, determine if they're positive, negative, or none, and then come back and I'll fill in the rest of them. So you can go ahead and hit pause. Right, so test scores and shoe sizes, there are none. Your shoe size has nothing to do with your test scores. This one's a little bit trickier. As you travel, you use up more gas. You have less gas in your car. So as you go further, you have less gas. So this one would be negative. The more you study, in theory, the higher your grade. Again, these are trends. There are always exceptions to trends. This one sometimes gets people hours in the mall versus money you spent. So the more time you spend in the mall, the trend is that you would also spend more money. So that would be positive. The speed of a train and the length of time it takes to get somewhere. So the faster you're going, the less time it takes to get somewhere. Because if the train's going 100 miles an hour, you'll get there quicker than if it's going 50 miles an hour. So the faster the train, the less time. So that is negative. We did a kid on this one, so make sure kids are still growing. So a kid's height and a kid's age should be positive. The taller you are, the older you are. How tall a person is and how fast they drive, that they have no correlation. And last, the temperature outside and the number of people wearing jackets. So as the temperature increases, we should see less jackets. So that's going to be negative. As one increases, the other one is decreasing.